Good morning, good afternoon, good evening to all from all over the world. Welcome to this new session of Indexed, organized by the Sfen. As you know, the Sfen is the French Nuclear Society, and Index is an international conference on the digital transformation in the nuclear industry. So our session today is dedicated to the presentations of case studies of new digital developments for the nuclear safety. We will be presented examples as diverse as tools for faster and more innovative developments of new nuclear designs, tools for earlier and more comprehensive checks of the agency from the start of their development to strengthen the V&V process, tools to enhance and to ease the application of the ESPN, which is the French pressure equipment regulation, and tools to better monitor the risk and sample the inspection programs, thanks to artificial intelligence. So Jean-Pierre Durand from Bureau Veritas will moderate this session. He will moderate it, but his own presentation that I will moderate. You can ask questions through the system, so you have an icon at the top of your computer if you have the Teams license, which is called Slido with an S. And if you click there, you can ask questions. And you can vote also for questions already on the screen. And the moderator will start with the questions with the more votes. So don't hesitate to vote. In case you don't have the Slido of our screen, you can try to have it through a link which should be on the chat. And in a way, for the questions, use the Slido, not the usual chat. The CVs of our speakers, our guests, are on the app. And now I will let the floor to Jean-Pierre, who will introduce the first speaker and moderate our session. Jean-Pierre, the floor is yours.
Thank you, Bertrand, for this introduction. So the first paper will be the paper named Framatome Design School, an innovative tool for dissemination of advanced digital practices. And that will be presented by Jean-Marie Hemery. He's the manager of Framatome Advanced Reactor Competency Center. He's in charge to deploy the innovative Framatome Design School, and it will address the question how Fra Design School can expand advanced digital practices. So Jean-Marie, the floor is yours.
Thank you, Jean-Pierre. Just started. Okay. So hello everyone. So I am Jean-Marie Hemery from Framatome, and I will show how our innovative design school is a very nice tool for the dissemination of advanced digital practice within the company and in the future outside the company. So a few words about Framatome and also the advanced reactor, what is in my scope as a strong driver for innovation.
Sorry, Jean-Marie, I think that we don't see your slides, unless I'm alone in that case.
I see it. I see the slide number 2.
Okay.
With the agenda.
Where's the agenda? So Jean-Pierre?
No, I can see only your icon with your initials.
Ah. So it depends on the computers, obviously.
Yeah, it's some issues that I can have with Microsoft Teams. So sorry about that, Jean-Pierre, but I guess we can go on.
Okay.
I hope that it is okay for the majority of the attendees. So, if so, just claim in the chat, and we'll see if we can do other
okay, carry on.
Process differently. So I will detail some examples of what we do in the design school and how we promote and advance new practices and new tools and how it's a nice initiative to push new practices within the company. So in one slide, Framatome, just to recall, we are dealing with all the life cycle of nuclear power plant or nuclear reactors, from the design up to the construction, for the manufacturing, the construction, the commissioning, the services, etc. And just to underline, to underline that even we are a very old company, we are managing very strong transverse transformation program, and one of these programs deals with digital solution, and so it is in that frame that I will detail some action we have within the company. So as I say at the beginning, so advanced reactors are very interesting driver for advanced numerical simulation, for instance, all the engineering practices. So just put the example of Astrid. It was the design of a Gen 4 demonstrator, and I was this project, the execution of this project started in 2010, and the end of the project was in 2019, and I was the technical project manager of Astrid within Framatome, and this project was led by CA. So you just see through example of advanced numerical simulation dealing with radiation protection and core physics, or dynamic solicitation for an accident situation, wave propagation, or strong CFD models or CFD plus system codes to have the whole representation of the nuclear system, and also slushing simulation for in the case of seismic situation. So after Astrid, so we develop many tools and new practices. So at the end of the project, and we decided to keep the momentum and to create a design school to help much more globally within the company, the various projects, to address the stakes of complexity mastering we have when designing our complex system and reactor, to also help for the knowledge transfer and development of architect engineers, and also to cope with the efficiency of design sequences, and with the question of early prototyping and also larger usage of advanced methods. So we create this design school to capitalize new practices, new engineering tools, and our main focus is to reduce the engineering sequences, to accelerate the prototyping, so the digital prototyping, but not only the physical mockups, through physical mockups or through simulator. So in terms of new engineering practices, you can see agile design phase. We managed that for hardware system. It was not so, it was quite new compared to what is done in the software development. Also, as a manufacturer, we also take benefit from design to manufacturing experience. And also, of course, we have to deal with designing new system, design exploration, optimization, architecture selection, trade-off management, and decision making. So we use digital tools for that. You see, for early prototyping, physical prototyping, we take benefit from Fab Lab, and also our virtual prototyping. You can see here immersive session in virtual reality to see the configuration of the system within all the room. And also you can see some colors in the various places. They are connected to the radioactive doses you can face when moving in the different rooms. So it's very original development we manage within Framatome. And also in terms of simulation, of course, we use a strong advanced digital simulation and to reduce the computational time using learning methods and also digital twin, etc. So this design school is focused to give a learning session internally, and also to manage a learning by doing phase, so sort of mini project, so to be much more in to get a practice experience of these new tools. So in parallel, also we can rely on a very innovative infrastructure, the SPOT. So it's a unique dedicated collaborative space gathering labs for brainstorming and creativity, for rapid prototyping prototype and virtual reality immersive experience. So we have the creative lab for innovation, the meet lab for sharing and for event, the fab lab for physical prototyping, and the CDRL lab for the virtual reality. And in our new premises in the south of Lyon, we have a dedicated space of 400 square meters within gathering all those labs, and it's a very unique tool, and we can rely on that to have also new engineering and new collaborative practices. So in addition, we take benefit from open innovation initiative, especially for to capture digital solution from startups or innovative companies outside Framatome. And just I will underline a few experience. The one dealing with concurrent engineering coming from Gigli methods and tool. The very innovative neural network generation by Adagos to also fully compatible with nonlinear physics. That is very new. Just a few words about the Elvis prototyping for simulation and INC of complex system, but my colleagues just after will go much more in detail on that. And also Ask for the Moon is a startup that help us to implement digital tool for to help the access of all the knowledge, and also to help for the knowledge transfer through community within the company. So all those experiences are very strongly beneficial and are the basis of this new initiative we are taking to open the design school, the spot and the labs to other external stakeholders and generated cross-wise added value. So a few words about Gigli. Gigli rely not on artificial intelligence and a big number of data, but mainly and only on human experience. So it's why it's Gigli speak about augmented human intelligence. So the point is to capture the knowledge and the experience of experts through a very innovative database. Also to capture the design rules and some constraints. And the approach is fully compatible with the system engineering spirit. And taking benefit of this database, the rules, the knowledge, the criteria, etc. So it's the engineering pattern, the tools to capture and to create this new database. After that, through the tools called engineering intelligence, we can explore all the possible solutions we have, all the you can find, and take decision, and so validate the robustness of our decision. And you can play scenarios and validate those things. So we can cope with numerical things, quality, just or not just also times, money, physics, and combine all those criteria. So we can apply this approach to a very large variety of situations. Just an example coming from Astrid, we use the Gigli to select and to confirm the choice of the safeguard system of Astrid, and so we implement all the data, the design rules, etc., the criteria, and we explore the diverse solution, and to confirm at the end the robustness of the choice we have performed. Other innovative solution we validate and promote through the design school is coming from the Adagos startup, and so the point is it's a very new generation of IA, so we can speak about IA 3.0 to address the reduction of models to be applied to highly nonlinear physics and strongly accelerate numerical simulation. So we apply that to a very challenging application in the frame of CFD models, and I will just show you after. So we have two examples of the comparison of and the direct simulation or the initial simulation. So you can see on the left, it's just a dynamic melting of a melting front evolution. And so you have the solid and liquid interface. You have some thermal flux on the right, and you see the evolution in time of this melting front. And so you have a very nice correlation between the meta model and the direct simulation. And for safety, safety case of safety injection in a pressurized reactor, primary leg, you see also the comparison between the CFD model and the meta model. And so it's complex physics with thermal stratification. And you see the range, the acceleration factor between the CFD and the full CFD and the meta model. So it's 18,000 times faster than the previous one. So it's very impressive, and with that we can accelerate, of course, big simulation and do a lot of additional iteration and test new solution, new design, and go deeper in engineering studies. ELVIS, so ELVIS is early launch of validation via evolving engineering simulator. So the point is to integrate at early stage design the preliminary definition of the system, and to test globally the behavior and to simulate the control of those systems. And just skip, not say no more point on that, because my colleagues will detail after. So you see that we are in the frame of having tools to accelerate early stage for designing complex systems. That's the main goal we have. Last point on Ask for the Moon. So Ask for the Moon is to address, so it's the basis for the tools called Ask Framatome. So it's the way to accelerate the connection between people, to ask questions, to get answers from expert communities. So it's very innovative. So last word, to take the Chris Andersen message, saying that in the 19th century, the added value of a company rests on its production tool. For the 20th century, it's relied on its customers. And for this century, it is based on the ability to bring together and animate an ecosystem. So with this basis, we decided within Framatome to take a new initiative to put ourselves to animate the emergent ecosystem, and we have an emergent ecosystem within the nuclear sector with new actors, startups, etc. And so to open our design school and to create around the design school a design school hub, and to accelerate the connection with new actors, to have partnership with the education, startups and other stakeholders, and also in parallel to reinforce the nuclear future attractiveness for the new generation of talents, because we globally need to recruit a lot of people. So you see, we are really connected to education institute, startups, and also provider of innovative solution. And that's our new proposal to animate the emergent ecosystem through the hub based on our design school and the spots and the labs. So thank you for your attention.
Thank you very much, Jean-Marie, and thank you for being punctual and on time. We can open the forum for discussion. So we have a first question. Adamos MetaMod can deal with different initial boundary condition in comparison to CFD case. So that's for regular specialists. Can you answer that?
Yeah, yes, we can. Based on the learning phase, after that we can rely on various change in the boundary conditions. Of course, there are some limitations, but they are not so strict, and we can. This reduction model process is very powerful and very stable, even for non-linear situation.
I have a question on my side that's very practical. It takes time to learn how to practice all these tools you have shown. Do you have a dedicated team to handle these tools, or is it a kind of self-service principle where all engineers are joining the school and using themselves the softwares?
No, in fact, we have different. We have learning session. We have learning session available, and also we have a rapid MOOC studio to generate video to explain the tools by experts or skilled people. So basically, it's a set of learning session, and we deliver these learning sessions through the design school. And also we have some practical exercise to help.
Okay, thank you very much. Last question, maybe, are these innovations already applied on EPR reactor, EPR projects?
So yes, we start from the future nuclear systems of the Gen 4 system because we are fully in an early design stage, and of course all the efficient methods are disseminated through the company, and the objective is to help the various projects, the various ongoing projects within Framatome to take benefit from that. So progressively, yes, the different approach are as needed use in the ongoing project. That's the main goal, of course. Yes. Okay. Not to be applied only for the future system, but also, and it is the case for services, for also for decommissioning project, or all the projects we have in the company could use for a part all those tools. Of course, yes, that's the goal we have. Yes.
I'm pretty sure you will be fully busy in coming years with all the new projects we have in the nuclear. So
yes, but we need to accelerate and to be more efficient. Yes.
Maybe a last question: do you have any cooperation with educational organization to adapt BCs or MEs accordingly for digital approach?
So we are the
Master of Science or.
Yes, we do some lessons in engineering school or masters, and we have connection with education, and our spots and labs are very frequently visited by students, and we do conference or lessons. Yes.
Thank you very much, Jean-Marie. Thank you for the clear presentation. So now we have to switch to the following presentation, that the risk mitigation for modernization of INC system using dynamic simulation solutions. That's a joint presentation between Guillaume Hemery from Framatome and Mr. Paen from CORYS. Guillaume Hemery is the R&D manager in Framatome, and Didier Paen is in charge of the innovation and business management at CORYS. So the floor is yours.
Okay. Thank you.
Perfect.
Thank you.
So it's a joint presentation. So as you said, between Framatome and CORYS. So CORYS is providing the tool, and Framatome is providing the use cases. So maybe first, so this slide has been already introduced by Jean-Marie. So I won't introduce it again, and maybe Guillaume can start with your presentation, and I will continue.
Yeah, so hello everybody, my name is Guillaume Hemery, I'm from Framatome, Germany. And the main topic is how to push the deployment of simulation in project to enhance the robustness of our design.
Okay, and I'm Didier Paen, so in charge of innovation and business development in CORYS. So CORYS, so we deliver a simulation platform, and mainly we deliver a full scope simulator, but due to engineering needs, simulation tools are used from first stage, from design, with the incremental extension of the scope. So this is why we provide services based on our knowledge on nuclear domain, so all along the design phase of the nuclear reactor. And so the part of the presentation are based on first what is the challenge, coming challenge for nuclear industry based on the growth of INC complexity. Then second part, Guillaume will explain use cases performed at Framatome, and I will conclude by what we are developing currently in CORYS to support the new project. So first is an overview of the complexity and what is the challenge for the nuclear industry. And you can see, in fact, that developing a nuclear plant is very complex in terms of interaction, and in terms of coupling, it is a very high couple. That means that nuclear plants are part of the most difficult system to develop, and complexity means difficult to understand and to verify. So complexity is the label we give to the existence of many interdependent variables in a given system. So it is the case in a nuclear plant, and complex interaction and tight coupling. So it is why we are a nuclear plant on the right upper corner of this diagram. Complex interaction are unfamiliar, unplanned, unexpected sequences, and either not visible or not immediately comprehensible as a system with multiple feedback loops that can baffle our understanding. And tight coupled systems. So there are systems that are more time-dependent processes, so they cannot wait. They are stand by until attended to. So those systems are more invariant, have a little slack, so we have no margin in the way to react in case of issue. And the systems are complex, so we have to develop large and complex INC sequences. We can have a comparison of what is done for software development, and we can imagine that we are facing the same kind of issue. And the first issue is that we are sure that we have some defect, we have some error in the INC sequence that we are developing. And the other conclusion is that the later we are able to fix an error, the higher cost it will be. So we need to identify a new method to provide new tools to test earlier and to test earlier with a representative environment in order to be able to shape the curves and to act early during the design, during the cycle of the design of the INC sequence, to be reactive on any error when it is produced and fix it as soon as possible.
So then I will continue. So Didier said that the problem and issue is the complexity. So here, this is some example. What is instrumentation and control? For some people, it's just some computer which are in a cabinet and you don't see them. The problem is when we are talking about INC, we are dealing with the human-machine interface for the operator. It is, let's say, 500 display that the operator will use. It has to be coordinated with the operational INC, which is almost 15,000 pages of diagrams. Safety INC, dealing with the protection of the reactor, you have 5,000 pages of diagrams. Or everything must be consistent with the operator procedure, which is almost 20,000 pages. So you can imagine when you develop a system, you have some specification which are more or less mature. It's quite difficult to see if it has been tested or not. The problem is the people who operate the plant are different from the people who will design the system. So sometimes the designer wants to make something very good for the operator, but the operator says this is not what I'm needing. And everything will be tested during the test bay. The problem is how the system are big, complex. It's quite difficult to get at the same place during the same time with a good configuration every component. So mainly it will be done on test bay or postponed on site. And for each plant, you have a full scope simulator where the operator will be trained. So sometimes you discover engineering mistake during the preparation of the training tool, which is not the idea. So what we want to do is to move and to go from the specification INC design and to avoid as much as possible late detection of implementation error, late design correction, and to redo everything as it will lead to delay and extra cost. Next slide. So we have sketched up, let's say, a strategy based Elvis, named Elvis, as Jean-Pierre said. So this is the early launch of validation. We want to use the simulation, a simulator, so many simulation put together. The purpose is to test the engineering data, so try to see if what we have designed, what we have done on paper will work at the end. And of course, this simulator must be evolving because it's good to want to start at the beginning of the project. The problem is at the beginning of the project, you don't have all the data. So one example is this stepwise strategy where we said, okay, we should start with something who put the people talking together, very important after the COVID phase. It's the human-machine interface preparation. So to see how the system will interact with the operator, which are very complex. And then we said, okay, then when this has been decided and we are all talking about the same system, then you can start the design of the system. You can put what has been drafted on paper, you make that in the simulator and see if it's consistent with the human-machine interface. And so now we're working in open loop. And then the step 3 is where we put some process model to have a dynamical behavior. And this is the part where we do functional testing, where we discover a lot of problems that cannot be seen on paper. Later on, when you have this kind of simulator, you can prepare the commissioning, try to validate your commissioning procedure, and then the step going to a full scope simulator is easier. To do that, we are using the technology of CORYS. Next slide. So here has been shown, so with this simulation, what we want to do is to have some blocks that we can combine, and this allows some engineering practices. If you want to make human-machine mock-up, for example, if you want to test different operator view, if you want to make human factor engineering analysis, if you want to test the consistency between your procedure and your system as it has been implemented, or functional view. So this is what we want to do all along the V cycle, the development cycle of the system. Next view. So here's an example how we can do a human-machine interface development. So everything is designed on paper, and then we were asking the operator if it's okay or not. You can imagine how difficult it is to evaluate if a human-machine interface is correct on paper. So now we have the possibility to put that in the simulator, to ask colleague operator to play with the system. At the beginning, you just play to say, yes, this is what I want, or there is too much digit or too much information, or this is too complex to access to this display. This is this kind of thing we can address from the beginning. Next slide. We can define also some, and this is the point, I don't want to say this is a mistake. Here we have two displays that have been verified on paper. They are compliant to the specification, but as we have a small trick in the specification, that's on one side, when you have one display, the train 10 must be at the bottom. If you have more than 2 fluids on 10 must be at the top. That means that will make the operator crazy when you have to use a system which is not consistent. But this is not a mistake. According to us, we design that according to the specification. And if you work according to the specification, this is not a mistake. That's why it's very important also to verify the specification at an early stage. Next. So we are working also on specification, because doing some specification on paper, it's quite complex. So what we are able to do with this kind of simulation is translate graph set or idea in the simulator, take the system PNID, the system as it would be designed, and try to see if the INC specification is working as expected. So here we work that on an isotope production system, and then we develop a new mindset, which was a simulation-based design. So it was during the crisis of the COVID crisis with Canadian people, so it was very good. It's difficult to want to explain some problem by phone, by Skype. It's difficult to say when the valve is opening, then the one will close, and it's not possible. So we were making some video, we were able to change the simulator, send an update, and then at the end, the customer was very happy. Next. When we are designing a simulator and we want to test the INC, it's, as Didier said, very complex. So you can have a look here on the procedure. This is only 6 steps, but this is, I will not go in detail, what you need in your simulator if you really want to be sure But first, your procedure is correct, and then that your system will react as expected, which is not so easy with the complexity of an INC system that we have to deploy on an EPR project, for example. And then last but not least is when we are doing functional verification. So when you have the human-machine interface, when you have the operational INC, the safety INC in your simulator, and when you have added your process model, so here it was on the emergency diesel generator, then you can make some tests, and here you have the return of invest, because it's difficult to convince people to spend money at the beginning of the project to avoid mistake that they will do and identify later. And when I say later in the nuclear industry, it could be 5, 10 years later. So here we have a return of investment on this diesel. We say that we have identified that 1/3 of the mistake was due to implementation and 2/3 was due to specification. And we evaluate that when you spend 1 hour at the beginning of the project, then you save at least 6 hours on site. And I say just at least. On the nuclear power plant, it's very complex to make some changes, so this is just at least. So, Didier, back to you. Oh, I'm sorry, take over just. So there is no big or small project, it's not too expensive, and yes, we want to master the challenge of INC integration.
Okay, so back to the tool. So as explained by Guillaume,
We have 2 minutes left.
Okay, I will be short. Access of data is very important, and this is why we promote the use of tools and the use of what we call MBAC tools, so model-based for system engineering. And the idea is to provide tools that will able to aggregate all the data when you are drawing your INC sequence. And the tool will also perform the traceability, so between requirements, between allocation to units or the version management. But also we are adding some business implementation inside the tool to implement the engineering process. As example, for Framatome, the way the redundancy and duplication are applied to the sequences, to the different parts of the INC sequences. And in terms of tool, as you know, the current tool for INC sequence are more drawing tools. Mainly of them are based on Microsoft Visio. And now what we provide is tools that are able to draw your sequences, but also to simulate them. So we can say that we are able to provide data-centric tools that are able to aggregate the properties of any feature, allocation, and so on. But those tools are also able to export the document. And based on this, we are then able also to build the sequence and then simulate it. So that's using a kind of a MBAC tool, as you have in the middle. You are able to export the document, as it is already the case in the Framatome process, but you are also able to put the data on any sequence to perform the allocation, then to perform tests to verify your specification that you have done in the INC sequence inside the tool. And what next? So for the future, the idea is to be at a higher level for automation, so to be able to generate, as we can, HMI sequences or also process sequences based on the mechanical drawing, as long as we are able to identify some schemes inside the mechanical diagram. So this is the generation of models, and once you recognize the scheme, you are able to generate the model and simulate then in the simulation platform. So this is we have actually R&D project on that subject, and that's all for us. Thank you.
Thank you very much, Didier and Guillaume, for that presentation, clear presentation. So we can switch to the questions. I don't have any for the moment visible. So I have a question from my side. How long does it take to adapt the LV's tool to a given use case? Is it a matter of days of work, or weeks, or months, or years?
I want to say it depends. The problem in the nuclear industry, you have some small project, then it's, if you support already the technology, the system, it's a question of days. If then you are coming with a new technology and with a large DCS project, then it's more a question of months. So you are first to adapt the tool. Sometimes just the naming convention between, you have the by EDF ECS coding system, but you have also some German other ones. So then it's more a question of.
Yes, and also I will add that we expect that it will be more and more efficient because some years ago, specification went under Visio, so the conversion, translation of Visio scheme to a model was not easy to perform. No, tools are more adapt to a model transition. And then for LVs also it depends of if the test have to rely on a model, and if we need a model to perform the test, it can take time to develop the adapt model to the test of the sequence.
Thank you. Other questions for related to the benchmark? How other industries are practicing? They have similar tools.
In the simulation world, there is different tool, but when you want to make something big and in real time, then you need some expert. And that's why we let Didier answer.
Yeah. For you know, I have some overviews on other industry and process industries, and I can see that they are using tools for testing, but mainly at a commissioning level. And what is important in nuclear industry is that we are able to perform tools from the design phases. So I think it's a good point for the nuclear industry.
And what is the impact and interest of information standards to the benefit of the presented tools?
Can you repeat?
What is the impact and interest of information standards to benefit of the presented tools? So I think that we have standards to be applied.
I think it's a kind of standard for exchange of data from one tool to another.
Yeah, I think so.
We are on our side, at least we want to push, and so it's very expensive if we have to redefine every model every time. So what we want to push, and we have contact with our colleague from Advance and EDF, is how we can now in the future try to industrialize simulation strategy. So try to get a model, exchange that to someone else, and then there is this functional mockup FMI standards, what we are using and so on. So we try to standardize as far as possible to optimize also the cost to build this kind of simulation.
Thank you very much for this clear answer. I think the time is over, so we have to switch now.
So Jean-Pierre, now you are switching from moderator to presenter.
Yeah.
And you are going to talk to us about how artificial intelligence is used by les organismes notified bodies to support the compliance assessment, the compliance to the ESP, pressure equipment regulation. So now the floor is yours, Jean-Pierre.
Thank you very much, Bertrand. So brief summary of what I'm going to present. So I will explain what is the scope of a notified body, because it might not be known from all of you. I will explain the capitalized experience we have gathered so far, and what is the limit of the current tools we are using today, what artificial intelligence could bring, and what could be the benefits, and a few words of conclusion. So what is a notified body scope of work? So just a few words about Bureau Veritas. I've forgotten to tell that I'm the director of the nuclear agency in Bureau Veritas. Veritas is a world leader in test, inspection, and certification. So certification is well known for all kinds of certification, ISO certification 9001, 14001, and so on. I'm going to focus my presentation on the industry. That's the part of the business where we have all our nuclear activities. Just for the story, so the birth of Bureau Veritas is from Marine for the certification of ships. So what are services in Bureau Veritas for nuclear activities? We perform testing in laboratories and as well second part, third part inspection, certification and training. And that's performed between the different actors you have on the slide, the supply chain or the manufacturer, during the design and the construction. So we are doing as well these activities. And we in support as well to nuclear operator. I'm going to focus in the rest of the presentation about our services we are providing to regulators in the framework of pressure equipment, nuclear equipment. So what is the mission in the domain of nuclear pressure equipment? So Bureau Veritas is an independent third part notified body, often named NOBO. We assess the conformity of nuclear pressure equipment because nuclear pressure equipment are designed by the designer, produced by the manufacturer, but bottom line, it has to comply with nuclear pressure regulation. And the regulation tells that we need a third part to assess the conformity. So it means that the designer, the manufacturer, have to submit their goods to a third part to assess in a independent way the conformity of the equipment. So we set up and we perform inspection plan, design review. We are making computation as well to review the design. And the bottom line, we deliver a conformity report to regulator, or if we are talking about class 1 equipment, or we deliver directly a conformity certificate to the manufacturer. And the scope, when we speak about pressure equipment, that can be the vessel itself, the heat exchanger, steam generator, pressurizer, piping, valves. And the scope of our assessment is that the design, the prefab, before any assembly on the site, the assembly on the site, and the final pressure test. And for that, Bureau Veritas needs key licenses. We need to be certified 17020 ISO certification, and we need as well to be notified by the regulator. And in France, that's ASN, but we have as well worked for other foreign regulators. What is the capitalized experience from Bureau Veritas in the pressure equipment? We have, let's say, applied and verified the compliance for the pressure equipment over the last 15 years with a new regulation in France, but as well for the PED in UK. So we have thousands of reports and findings meaning non-conformance or non-compliance on the design, the manufacturing, the assembly, the pressure test, and all the equipment I mentioned earlier. And once we have a finding or we have a non-conformance, so it's shown to the manufacturer or the designer, and the designer has to reply, telling in which way he wants to repair or to bring additional information that is not known from the notified body that could reach to the compliance. So we have a large volume of, I would say, recurrent standard cases. They're quite simple cases, mistyping of something or missing information, but we have as well a significant volume of complex technical cases that took at times a couple of months or even years to reach compliance. And these cases have involved our best experts from Bureau Veritas, but as well from the regulators and manufacturer. That's a considerable asset for the future project, because so we want to learn, we want to progress, all of us in the nuclear domain, and for the future project, we don't want to replicate the mistake we have had in the past. So that's a matter of collective efficiency and credibility. The limit of the current tools we have today. The digital transformation of nuclear activity is very recent. So since 2 years, we have a new platform that Benoit Etave will present it later on. This platform, that's a platform where we post all our findings and comments related to in design, review, or inspection, and the manufacturer and future operators are replying till we reach the compliance. That's fully digital, but it's quite recent, only since 2 years. So before that ESPN digital platform, we hadn't any real digitalization of the data. I will show you the example. We had the Excel files, we had the Word files, SQL databases, but that's not really native digital information. And we need to value the past experience, this non-fully digitalized information. And if we want to make a summarize of thousands of findings, reports, that's not manageable for the collaborators. And it would take years to get it. And I'm not sure it will be used finally, because it will talk only to specialists. So just to give you an example, here is an example of the database, SQL database, where we have the log of all our findings, the thousands of findings I told you about a couple of minutes ago. We have some information, metadata about what is the class of the equipment, the type of equipment, the manufacturer, and stuff like this. And we have a long list of findings. And if we click on that, we get a brief description of the original deviation. And if we want to know what was the deviation or the non-conformance, so we need to dive in another Excel sheet where we have all the description of the non-conformance and the iteration with the manufacturer till we reach the compliance. So that I remind you that these documents are 10 to 15 years old, or even quite recently we are using these documents. So make a summary of this manageable for knowledge management, and that's not really easy. So we have considered artificial intelligence support for that. And so we have in mind a 3-step development of artificial intelligence to support inspectors in a similar cases in the future to get the best of our database from the past. So first, we will extract the data from existing document I showed you. So we have already selected the document with an automatic extraction of the text report, and we need to convert as well these extracted text into real digital data. We need as well on the second stage to, let's say, thanks to artificial intelligence, to learn the syntax and vocabulary, because in the documents, finding can have the meaning of a comment, a non-conformity. When we talk about a non-destructive test, it can be penetrant test, radio test, ultrasonic test, or something else. So the software artificial intelligence needs to know the vocabulary and syntax to get the best of the text we have and to make an indexation and classification of the data. And the third stage is to fine-tune the search parameter and the search reports in such that we get in an output a suggestion of similar cases for comparison purpose. When we will perform an inspection in the coming weeks, months, or years. That would be really useful to type in the kind of Google type search tool, whether we have had a problem of heat treatment on a welding, on a valve in a given position. So the benefit of artificial intelligence for Bureau Veritas is threefold. So But I have to remind clearly, or to tell clearly, that the artificial intelligence will never take decision on behalf of the inspectors. But we expect support in the 3 following domains: in the training of inspectors, for the qualification and training that's really efficient to train people on real cases from the past, and as well to learn about the evolution of inspection doctrine, which has evolved over the years. And the second level of support would be the risk-based inspection. So knowing that having such a database, we can extract what are the most risky operations, what are the statistics, and focus our attention on the operations that are at risk from a conformity point of view. And finally, that will ease the instruction of the future finding based on standard case we have seen before or complex case we have already had in the past. So as a conclusion, Bureau Veritas was a precursor of ESPN digital platform, which will be presented later on by Benoit Etave. And now we are focusing our effort on knowledge management, because that's very good to have a digitalized tool for the future, but that's even interesting as well to have the best of our archives and to get the best information from that in a classified way, in easy access. So the status as of today, that we have identified the document, the database are selected. We have already identified artificial intelligence partners, and we have checked that it was feasible. That was not a dream, not achievable, but that's really feasible. And we are ready now to launch the proof of concept. Thank you for your attention.
Thank you very much for your very clear and attractive presentation. You have just said that you are ready to launch a proof of concept. Yeah. When is it planned? We are very impatient, very anxious to see that.
I think it will launch in the first quarter of this year.
Oh, okay, so very rapidly now. And so in this proof of concept, will it be applied on current manufacturing and current inspection, or?
That's not the plan today, but I think that Benoit can answer it on the ESPN tool, because this tool will gather a massive amount of information, and I think that the statistics tools will be put behind that, and with artificial intelligence to highlight the main risks for the project, but that's another story.
And do the people who are currently digging into the past history and the past files, do they expect a lot from the artificial intelligence doing the job for them?
Yeah, that's a good question, because we have a young generation coming, and they are much more used to type on this kind of tool, like a Google search tool, than diving in archives from the others with Excel files, Word files, and stuff like this. So we expect a lot from that, because that will be easier access. And you might know that once we have an expert making a summary sheets on a given, I would say, technical case, it will be really useful for the expert himself, but for the others, and transmission to the others is quite difficult. So having this quite of intelligent search tool, that will ease a lot to recover our archives.
Any question from the other panelists? You are allowed to ask questions to Jean-Pierre. It's the reverse time. You are you're among the moderators. Is the presenter, so you do benefit from that. I have one question. Is there anything planned to check by sampling or in some way that artificial intelligence is not going to forget something important in the past files.
Of course, we are going to do that, but we don't have yet the protocol to test in which way the artificial intelligence is exhaustive and has treated all the cases. But we'll think about that. That's a good advice.
Yeah. And I think it's a general question for artificial intelligence throughout through all the projects.
But again, I would like to underline that they will never take decision on our behalf, and so that's just, it will show us similar case or case which would be similar in for reflection and for to feed the thought of the inspectors.
Any other question from the panel? I see congratulations on the slide for winning the international tender at Ignalina in Lithuania.
Thank you very much.
So for the reactor dismantling. So you can have two congratulations. This one and the one are very clear and attractive presentations. It makes ESPN nearly attractive. So
that's a long way.
That's good. That's good. You're coming from a long way. So thanks a lot. You can now switch back to your role of moderator for the next presentation.
So now we will switch to the digital platform ESPN Digital. So that was a good teaser for you, Benoit. What is the ESPN platform? So yes. Benoit, just a few words about Benoit. Benoit started his career in 2008 as a new build engineer in EDF, and now he's a project manager to develop the digital platform ESPN. Yes. Thank you.
Thank you, Jean-Pierre, to introduce which is a nuclear pressure equipment, a notified body, and ESPN Digital. I want to make ESPN attractive too. To make ESPN attractive, I will explain how our solution, our ESPN Digital, achieve to digitalize the complex compliance assessment process for nuclear pressure equipment. So first, what is a nuclear pressure equipment? Jean-Pierre has said, Jean-Pierre, it's a reactor vessel, a valve, a piping, a pump, and which sustain pressure and radioactivity. So ESPN Digital, what is ESPN Digital? ESPN Digital is a tool to perform compliance assessment of French nuclear pressure equipment. Nuclear pressure equipment is a reactor vessel which have a lot of requirements we have to respect. So now, why nuclear pressure equipment required the development of digital tool for compliance assessment? First, because the compliance assessment of an NPE is NPE nuclear pressure equipment is complex and involve many stakeholders. In France, the replacement and the installation of NPE is highly regulated. The stakeholders are expected to deliver numerous documents for which there is not harmonized template or practices. Oh, sorry. Okay. To certify an equipment, we are 4 stakeholders. First, the operator, EDF, for example, which exploit and maintain a nuclear power plant. Secondly, the manufacturer, which build the nuclear pressure equipment. And then the notified bodies, like Bureau Veritas, which review the documents provided by the operator or the manufacturer and inspect and certify the new nuclear pressure equipment. At last, there is the French Nuclear Safety Authority, ASN, which ensures the whole process complies with the regulation. ESPN Digital was created, like Jean-Pierre said, to harmonize NPE compliance assessment. In 2015, several compliance assessment error leads to important delays and overspending on INDF project. So this incident could be explained by several factors. First, long and unpredictable compliance assessment duration. Secondly, heterogeneous practices and semantic between the different actors. And finally, challenge to monitor NP compliance assessment. So between 2015 and 2018, Sfen lead a program to establish target technical reference approved by certified entities and French Nuclear Safety Authority. Since 2018, EDF have been developing Sfen Digital with 15 partners like Bureau Veritas, from the French nuclear industry, so manufacturer, notified body, and nuclear associations, which represent this manufacturer or notified body named Sfen and Sfen. At the end of the project, Sfen Digital is expected to first reduce by 20% compliance assessment cost, optimize resources and better planning and management, reinforce the quality and the safety of NPE through the standardization of practice and the end-to-end traceability. I will give you some example the presentation, and finally cover all assessment action within a single platform. Sfen Digital was developed through the program Switch. The digital transformation program aims at supporting the EDF nuclear engineering unit in making the most of new technology and practices. It's carried out by 3 partners. First, EDF, and Capgemini and Dassault Systèmes help them to develop this new technology. The program has 4 pillars. First, set up system engineering across project lifecycle. Second, passed from document-centric to data-centric approach. Third, standardize and digitalize processes, engineering processes. And at last, work in external company to earn competitivity and facilitate exchange. Now, Sfen Digital, which is the 3 main services. Sfen Digital is a digital platform should onboard the whole nuclear industry based on PLM technology from Dassault Systèmes. This platform centralize and facilitate exchange thanks to the collaboration chamber. It's permitting collaboration and unique vision on certification between all the stakeholders. Second service, it supports the production and harmonize deliverables thanks to the digitalization of Sfen guides in data approach. And finally, it proposes a global and consolidated vision for nuclear pressure equipment compliance assessment. Today, the platform is able to manage an end-to-end compliance assessment. In the future, 1,000 users of Sfen Digital can use this platform for 1 year. To conclude, Sfen Digital will become the standard compliance assessment tools for NPEs across the French nuclear industry. We work with many companies to keep this goal. It already covers 80% of compliance assessment process, so the solution is already supported by 31 partners across the nuclear industry. So as you can see, this platform is now ready to welcome the NPE certification for all EDF projects, and in particular EPR2 plants. So I'm finished. So if you have some question, I will be pleased to answer it.
So thank you, Benoit. A very clear presentation, and that's a good link. That's fortunate, but that's a good link between our two presentations. We have also a couple of questions. Could this ESPN digital could it be used for SixFoisSept?
Yes, you can use the collaboration chamber, which permit exchange on document and to receive some findings from the notified body and follow the certification, but the help for document redaction, writing. So excuse me, it's not possible because it's only for French 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 law.
Okay. Is it made mandatory to use the ESPN digital for all the stakeholders in EDF and PE contract?
It will be. We began to contractualize ESPN digital in our contract. For example, for EPR2, since January 2021, we put ESPN digital as a requirement in our contract. So in EDF approach, we want to have 100% of contract in ESPN digital by 1 year.
Of course, this ESPN tool works if all the players are playing on the same field. So
yes. If we have a data approach, like you said, so the more there is a user, the more data we have, and the more data we can transfer to a notified body for making analysis on findings, on comments, and your AI could work with this data. We work on open API for to give us some data, and you can work on your data.
So to what extent ESPN digital has actually simplified the ESPN process for users? Or I have a similar question. Do you have simplified the ESPN process before putting in place ESPN digital? Or what was the route?
We harmonize. We harmonize because to simplify it's difficult. The law is the law, so we have just have to respect the French law, and it's not possible to simplify, but harmonize and standardization is the best way to give predictability in our certification assessment.
Does the tool ensure some secure conservation of data? Sorry. So how the tool is secured?
It's secured as all EDF tool. It's on our server EDF, and the data is fully protected by EDF services.
Okay, which productivity benefit do you expect from this tool? You already mentioned 20%.
20%. 20% on cost and on planning. It's first on planning, then we earn 20% on the cost.
Okay. And what is do you have any plan to connect to the PLM system for instance, for EPR2 design team or stuff like this? No.
Yes, we work on it since September 2022, and we have the goal, the aim.
So we cannot hear you, Benoit. Am I alone?
No, it's okay.
You are not alone.
Image is frozen and you have lost
Yes.
Benoit.
And I'm alone too, or
You're back. No.
Perhaps some connection troubles.
Yeah. Anyhow, that was the last question.
Benoît, il y a peut-être une solution qui est de débrancher la caméra, désactiver la caméra pour
Yes.
être sûr
Ouais,
que
pour
le son
récupérer
passe.
la bande passante.
Oh.
it's okay?
Yes, we
You
can hear
understand
you.
me?
Yeah.
Yes. So I said that we work on the connection between PLM IPA2, which which permit to design the process, the IPA2 plants and the ESPN Digital, and the aim is to connect the two platforms in December 2023. We work on it. We work on it, and I hope that we can make digital continuity, data continuity between this platform at this date.
A very interesting project. Huh?
Yes,
It will be
yes,
fully
yes.
fully digital
And
tracking.
then the next objective goal is to connect SPN Digital to construction PLM, which permit to transfer conformity of nuclear pressure equipment, which was manufactured in several places in the world to the construction area to maintain the conformity during the construction.
Thank you, Benoit. Thank you for this clear presentation and clear answers. So we don't have any more questions. We are going to switch now to the last presentation from Sophie Guérin from SixFoisSept. So Sophie Guérin is head of data science at SixFoisSept, a specialized data science company. She has overseen the development of semaphore risk monitoring tool, and she will make a presentation about the semaphore risk monitoring tool, in which way semaphore tool can bring in the domain of nuclear safety through risk-based inspections. So the floor is yours.
Thank you, Jean-Pierre. I'm going to share my screen. Okay, is it okay for you?
That's okay.
Okay, great. So here is how I'm going to show you. I'm going to introduce us and explain who we are at SixFoisSept, what we do. I'm going to give you some feedback because semaphore is actually in use in the civil aviation sector, and it's been since 2018. So I'm going to just tell you what we've done for them. I'm going to talk to you about the methodology and then show you a demonstrator of our tool to be more concrete. So first, who we are. SixFoisSept, we are our own subsidiary of the Etave group. And what we mainly do is that we are experts in data science and AI. So what we do is here that we take data sources, we take data, and then we put them into databases, and then we do some machine learning, some predictions, and data visualizations, all data manipulations to build useful tools for business. For instance, what we can do is that we can provide a comprehensive view of customer behavior. We have the semaphore risk monitoring offer, which I'm going to describe later. We can analyze text via methods like natural language processing or text analytics. And for instance, we can classify medical imaging reports. We can also analyze videos with computer vision and detect, for instance, anomalies of the maintenance of railroad tracks. We also do data visualizations and activity management tools, and we can also analyze the sentiment of social networks. So this is a big picture of all of activities. And now some feedback on the semaphore risk monitoring tool in the civil aviation. For the Civil Aviation Safety Agency, we've built several semaphore tools. Some of them are for the oversight of organisms. For instance, there are production organisms in the civil aviation area, and there are about 200 production organisms. And one of the missions of OSAC is to inspect all these organisms. All of them are going to be inspected. Some of them are going to be inspected more thoroughly than others. So here there are 14 performance domains that have been defined, and the risk is measured for all of these domains of performance. And according to the risk, some of these domains will have an in-depth monitoring of the domain, and some other we have a light monitoring. So the idea is that here, according to the risk, the modality, the audit modality will change. Another semaphore tool we've put in place for the Civil Aviation Safety Agency is about aircraft surveillance. Today, there are about 15,000 aircraft registered in France, and OSAC has a mission to inspect a sample of them every year. And so with the semaphore tool, since 2019, they extract an annual sample of about 400 aircraft. And this sample is not just a random sample. It is a sample that takes risk into account. So there is a risk score that is computed for any aircraft registered in France. And in the sample, the most risky aircraft will be considered. And the sample will also respect some business constraints, such as it will be representative of the fleet. The idea is that OSAC doesn't want to inspect only very big and very complex aircraft, but they want to inspect any kind of aircraft, very small one, very recent one, and so on. So the semaphore tool allows OSAC to select the number of aircraft they are going to see this year, and then delivers a sample of aircraft that will be representative and prioritize most risky ones. So our tool, our semaphore monitoring tool, what is it? It is a tool to define and monitor oversight programs based on the risk. All KPIs will be seen in a dashboard. So mainly in the end, the tool is a dashboard and a parameter application tool. What is it for? One of the main problems is that you might need to justify your inspection plan and explain why you have seen this item or this item and why you haven't seen this item. And with the semaphore risk monitoring tool, as there is absolutely no black box, you can always justify and explain why you have inspected this item or this one. And it's based on a reason, not just a random sampling. It's based on the risk and on some other business constraints. So it's also it also has the goal to improve the global quality, because the risk we measure is a relative risk. So there is always a continuous quality operation. And on resource optimization, the idea is that if you focus on most risky items, of course, you optimize your inspection globally. The key feature of the tool is that it is industrial. Every data is updated every night. It is full web, so it's responsive, and it's an evolving tool. You can always add some more data, any kind of data in the tool. So a few slides on the methodology. To measure the risk, the first thing is to measure some KPIs. The risk is generally described as the crossing of the probability of occurrence of an incident and the severity of the consequences of this incident. And so you have to define and measure a set of KPIs to compute this probability and severity axes. And some of these KPIs will be, for instance, was there findings in the past? Was these findings closed in due times? And so on. This is some classical KPIs. you can aggregate any kind of data source, internal databases, structured or unstructured feedbacks, for example, PDF files, open data, internet, the ISN site, for instance, and so on. Any kind of data can be put in the tool. So next step is that you want to standardize your indicators. You have all these kind of indicators you've computed, and now you want to put them at the same scale. Because if you want to aggregate them in one risk score, the necessary step is to standardize them all on the same scale, for instance, a five-level scale. Step number 3, you are going to consolidate an accurate risk score by our methodology is to use a business allocation process method because it involves experts. So experts are going to weight KPIs according to the importance they have in the risk measurement, because of course not all KPIs have the same weight. So one of the advantage of doing this method is that we have a project additions of experts and also a business input, which puts the models even more accurate. And then we are going to create a RBO program. So I've shown you two types of semaphore programs we've put in the civil aviation. There is one where the surveillance, the oversight is exhaustive, and you are going to modulate the nature and the frequency of the oversight. And the second type of semaphore is where you are going to select a sample of items you want to inspect based on a general population. It's also an industrial process, it's daily update, and also to accompany semaphore, because we always create a daily update data quality dashboard, because this way you can have a continuous assessment of the data quality and correct any mistakes there is in the database every day so that your semaphore tool is completely efficient. Just some feedback on what we've done so far in the nuclear sector. We are a semaphore that will be in production on the February the 9th, so it's very close, and we are at the end of the project. The idea is that we've built a semaphore to modulate the oversight of design documents for pressure equipment. So we measure the risk for any regulatory points, and we create a tool allowing all inspectors to visualize for any new design document to be audited all the regulatory points and the associated risk. So the idea here is that we have an exhaustive surveillance, an exhaustive oversight, and we are going to modulate the nature of the oversight according to the risk. It's based on PDF files. We have consolidated all information from PDF files in an accessible database, and the idea is that this database can be used for other analysis, for example, to aggregate information at the manufacturer level. And what I'm going to show you here is a demonstrator we've created for last year World Nuclear event. Here the story is that it's all anonymized, and we are creating an inspection plan for all operation, for all production operation of a nuclear power plant. Okay, so it's in French, but I'm going to explain it anyway in English. You have here all kinds, the way the sample is put initially. So initially, the sample will respect all the ISN standards and needs. And for instance, for thermal treatments, there will be at least one inspection by equipment, one inspection by site, and so on. So this is just all the criteria that the sample has to respect at the beginning, and it has to be at least 900 inspection. So this is how we initiate the inspection plan. We can see here, this is the inspection plan. Each line is an operation, and each column here is an equipment. And here you have the blue squares where we are going to inspect this equipment. For instance, for the operation A21, we are going to inspect equipment 1 to 12. everything, there is no black box. So if I click on operation A19, I can always go down and see why it is risky. It has a risk of 5, and mainly because there was many findings in the past and complementary demands. And there is an event on the ISN website that is related to this kind of operation. So all of this increases the risk. It's completely transparent and allows any inspector to see why this operation is risky or not risky. And what I would like to show you just before my time is off is how to modify the inspection plan. Several things can happen over time. The ISN can the sampling rule and say, now for thermical treatments, for instance, you have to see at least one operation by treatment means. And so you can check the box and update the inspection plan. And it will be updating. Here it's calculating, as you see here. And you have your inspection plan, and you are going to see some new operations that will appear here in a deep blue. So these are the new operations in deep blue, and the operations that have been removed are in gray. Another thing that can happen is that over time, for a certain type of operations, there can be more and more findings. And then if this happens, there will be an alert on the dashboard. And this alert will say, oh, on this type of operation, there are many findings. So there is a suggestion that you might want to see these operations. For instance, I might want to see operation A19, and I check the box and safeguard. And I'm going to see the A19 operation. Here you see there are some new equipments I'm going to see, and I'm going to see them on an unexpected visit. And the last thing I can do is, for instance, say on operation A20, I want to see equipment 12 because I have some other information that have come and that are not parametered in the tool. And so I'm going to check the equipment 12 of the A20 operation, add them to this inspection plan. See, the square is now purple for an unexpected inspection. And in the end, you just have to validate the inspection plan, and it will be your new inspection plan. So this was the demonstration of our tool. I think I'm just right on the time. So if you have any question, don't hesitate.
Thank you, Sophie, for this very clear presentation and dynamic presentation with a real case. So we have a question: how independent is from the ESPN digital? Is there any potential for common cause failure?
So far it is independent because we can have any kind of data source in Semaphore. So it's not, it doesn't have to be connected with ESPN Digital, but it can be, of course, connected with ESPN Digital.
Okay, about aeronautics plants and the aircraft, are the inspection priority produced by Semaphore significantly different from I had the same question, so Bertrand, different from those given by professional. So so is that different in nuclear industry than the aeronautics, and is that different from those given by professional in the Semaphore? But maybe Bertrand, you can detail because you want to compare what is done in aeronautics and in nuclear with Semaphore.
No. It's rather in aeronautics there is quite an experience, if I understand.
Yes.
So basically the plans, inspection plans produced, and the priorities produced by Semaphore, are they very different from the ones who would naturally be proposed by a professional or an expert?
What I would say is that they were validated by professionals. For instance, the first list of aircraft, the first sample of aircraft to be seen that we've produced in 2018, the inspector received it, and the 3 first aircraft that were very risky, the most risky, were actually down and could not fly. They were in detailed pieces in a garden. So the tool was validated by inspectors and surveillance responsible.
And does the tool sometimes provide priorities or ideas of inspection that the professional would not have thought about? Does it bring new ideas?
I hope so, yes, because it's based on many data and it's not so easy for a human being to analyze all the data and all the history of aircraft and organism. And in addition, what we've done for OSAC is that we've linked several semaphore tools together. We have the semaphore tool for aircraft and for organisms that manages the aircraft. And so for aircraft, one of the risky indicators, one of the indicators that increases the risk is whether it is managed by an organism that is risky. So for a human to analyze all the data from all organisms and from all the aircraft, it's really very complicated. And this is one of the advantage to use a semaphore product. It is to analyze more data than the human brain can.
Okay, we have a question. How susceptible is it to malicious attacks?
Yes, security and safety on server is a very important issue for us because indeed it is very protected. We have a very big attention on this matter because indeed it's very sensible data and many people would want to have all this data and all this list of aircraft and so security is really important for semaphore tool.
Another question related to the performance of the tool. What is the hit score of the tool? I mean, what is it? Is it able to catch issues on aircraft? Do we know this?
So it is not a prediction score of aircraft accidents, but it is a prediction score, almost a prediction score or aircraft non-conformity. And so yes, the most risky aircraft have the higher risk of being of having a non-conformity of having findings actually. So there is a clear link between the performance of the aircraft and the risk score and the tool.
I have a question. How do you digitalize the information from the past? Because you told us that you use the PDF files, so it means you have extracted the text for many findings from the past for the nuclear case, and you are feeding that in the machine, in the semaphore tool. Is that correct?
Yes, it's correct. So for the civil aviations, we have many data sources, which are all databases of OSAC. And for the nuclear industry, so far, the main data source is PDF files. So we analyze them and we do text mining on it to extract relevant information, such as the findings on the regulatory items and so on, the minor or major findings. And we structure all this data in a database to connect semaphore on this database. So it's mainly statistical and data science project.
I think that's really an important part of the project, because if you have clear and clean data, you can perform a lot of data science. But if from the start you have, I would say, dirty data from different, I would say, files, that's really not manageable.
Yeah, or it would take a longer time to analyze. But here, PDF files we are talking about are a little bit standardized PDF files. It's not just plain text, and it's not impossible to analyze plain text. We've done it in the civil aviation sector, for instance, to analyze incident reports. But here, for this semaphore, it's standardized PDFs. And some of them are pictures and some of them are non-pictures. They are just a real PDF file. So it's not the same way to extract information, but we've managed it. And in addition, regarding the data quality, we also have this data quality dashboard that accompanies the semaphore tool. So we can always see if on some regulatory items, for instance, there is no data, and maybe correct the way the PDF is done. So it's really important to have these two tools in parallel, the semaphore tool and the data quality dashboard tool. And it's doable. We've done it. It's the end of the project.
So it shows that we are way behind in nuclear industry in terms of digitalization. So because we are still using PDF like we are doing as well. Thank you, Sophie. That was really clear. Maybe a last question. Can the tool be used in infer safety rules with actual accident in order to upgrade these rules to make them safer?
We can definitely use it for safety matters. This is what I said really quickly, that we've done it to analyze all incident and accident reports in the civil aviation area. And so we can do it for any kind of purpose. The idea is if you have an oversight program and you can measure the risk to improve this oversight program, you can use it also in the safety area, not just in the non-conformity area.
I think that the meaning of the question was, do you have a feedback loop for the, I would say, the operator of the aircraft or the designer of the aircraft based on what you have discovered to make the aircraft or the operation of the aircraft safer?
We have mainly a business improvement or a business validation of what we've done, done as well as OSAC inspectors, as well as for OSAC clients, which are all the organisms of the civil aviations, which find the tool relevant and understands why OSAC has to monitor its inspection on this or this domain. It's mainly what we have yet.
Thank you, Sophie. Thank you all the speakers for being on really clear and on time. So I will let the mic to Bertrand for the final words and a wrap up.
Yes, thanks a lot. Huh? It's impressive to see the kinds of innovation and breakthroughs that are brought through those development in our industry. So it makes it very attractive too. I've seen a common breakthrough. I don't know if it comes from digital, but you are very, very much on time. So I hope it's a promise for all future projects in nuclear, thanks to digital. So you are very much on time. We would like to know more and to see examples. Maybe there is a transverse question. We have a few minutes. So we are here in the digital world, and for example, for new designs, we can make a lot of simulation and computation. And how do we keep some links, or what are the links organized with the real world? The one of the physics, if we need some trials or technology de-risking or checks on the physical world. Well, how do we manage the link between those two worlds?
Yes, I can bring some answers. So, of course, I take the example of the development of the S3 demonstrator. So it was a big amount of design, but in parallel we do experimental tests, and we use, for instance, the Framatome technical center for that. And also the point is to, when I say early prototyping, also to accelerate the link between the design and some practical things. So, and I also want to highlight some things. When you do a lot of computations, you are much more precise to specify the test, the measurement points, what you are looking for. So there is a combination between the two. And I have a long track record in simulation for engineering for a while. I started my career in the aerospace industry, and I always heard the point that computation will reduce the amount of tests, and it was not true all along. We never do as much as so many computations, and we do a lot of tests. And but we are much more precise, and we are much more focusing on things of interest, combining the two.
Thanks a lot, Jean-Marie. Very clear. Huh? Any addition to this?
Just may add, because of digitalization, we have more and more data coming as a site data, and we are able to compare what we are running in the simulator and what is the reality. And it is it's very interesting.
Thanks.
And one point, what we have observed when doing simulation on the simulator is that bring people together. And this is the connection that could be when a good company, a wide company like Framatome, where you have different silo, different people working on different topics. Yeah. With the simulator, with the digital tool, then it brings people back around one table, sharing the same scope, and then they start to speak together and not just exchanging email, and it helps a lot also to be on time.
Great, thanks, Guillaume. Jean-Pierre, as a speaker, you have any addition to that, or Sophie?
No, because I think that there are different approaches, because I think that in the case of the simulation, we are starting from, I would say, a virtual model, and we are going down to the floor. And in the case of what has been explained by Sophie on the risk monitoring, we start from what we have witnessed on the site, on the floor, to make it digital. Yeah. So there are two ways of digitalization. Yeah. So.
Yes. Okay. Thanks a lot. Now, thanks again to our speakers. It was most interesting, and it makes those projects really attractive. There will be a replay. The replay will be found in the near future on the web, on the index site. Don't forget that at 4 p.m. there will be tech demos. Those can be accessed by the app. If you download the app or through a link you can find on the site to the app. Index goes on until the mid-February. So you have all the program. It started in December. So it's a remote Teams conference with events every Thursday. So you can go on until mid-February with those events. And I think that's it for today. And thank you to everybody for being there. Bye-bye.
Thank you.
Bye.
See you at some other index event. Bye-bye.
Bye.
Thank you. Bye.